What's up, everybody? Welcome to your third C++ tutorial. Today we're going to be getting into variables, how to create variables and what kind of different variables there are. So we can use the code that we had left over from the last program that we did. Just delete this line and we can just work from here. Okay, so variables. Basically, they work pretty similar to the variables that we had in algebra. Set something equal to something else. So we can set x equal to 7, and then now x is going to be containing 7. It's going to be acting like 7. So the way we do that is we type int x equal to 7. So there we go. We have x is set to equal to 7. There we go. So now x is going to act just like 7 would. One thing you might have noticed is this int. So what is this int, you might ask? Well, this is a data type, and it basically tells the computer that x here, it tells the computer what x can be. Okay? So it's going to say that x here is going to be equal to an integer. But it could be equal to an integer, but it has to be equal to it's going to be equal to a number, but it has to be equal to a whole number. So that is what int tells x what the number is going to be. Only a whole number. Very important to remember. So you cannot put int x equal to 7.2. It's not going to work. When you run the program or when you try to do something with the x, you're going to get the wrong answer, or it's going to be wrong, because what it does is, because since int is telling the x that this is going to be a whole number, it basically truncates the 0.2. So if you have something like this is going to compile, it's going to work, but it's going to truncate the result, and x is going to basically be equal to just 7, which is going to be bad output. It's going to be a wrong answer when you try to do operations on the x or whatever. So very important to remember, don't make this mistake, that int can only work with whole numbers. So you say, okay, so what if I want to use a decimal? Well, then we use a double, and let's just say y is equal to 3.14. So here we go. This double here tells the computer, that y can equal to any number. So whole number and decimals included. So when you use a double, you can still write 7, and it's going to work just fine. It's going to work just as well as int. And you can also set it equal to 3.14. It's all going to work. So that's how double works. Okay, so basically there are 5 main built-in data types. And by the way, I don't know if I mentioned this before or not, int and double, these things are called data types. Just in case I didn't mention it before, I don't remember. But anyway, there are 5 main ones, 5 main built-in ones, which is int, here, double, float, character, and boolean. So okay, so let's see. So say you wanna output a character on the screen or something. Well, then we put a character. Let's see. G is equal to L. should probably, no, H, okay. And you might have noticed that I put the H here in these quotation marks. You need to do this or else it's not going to compile. So don't forget, whenever you set a character equal to something, don't forget to put them in quotation marks like this. Okay, so now G contains H. So now G, when we output G on the screen, the variable, it's when we, sorry, let me rephrase that. When we actually, yeah, I guess when we when we write the variable G to be outputted on the screen, the variable, what it contains, is actually going to be output H. Sorry if that's confusing, but I'm pretty sure you guys understand what I mean. So G is now equal to H. So G is basically going to be outputted as H. Okay, so let's go on. Next thing we have is so you might say, okay, so we use characters to output letters on the screen, but what if we want to output a whole word? Well, no problem. Then we use a string. This is also data type. You might have noticed that string here is not in bold like the rest of these. That's because all of these are built into the language. They're all built into C++, meaning that C++, basically, they're like native to C++. C++ knows what they are, and they're all built into the language. String here, however, is a user-defined type, so that means it wasn't built into the language. Somebody wrote it basically, and that is why we include IOStream, because the definition for string is included in this file IOStream. So if we did not include IOStream, this would not work, because it would look at string and say, the language will look at string and say, we don't know what it means. But we are including IOStream, and string here is defined so we can use it. So that's why, so just the point I'm getting at here, this is a good example of why we should include IOStreams. So remember to always include IOStreams in your programs. Okay, so let's go ahead and put string f equal to, just say dog. Okay. Now you might have noticed here that I also, just like characters, I also put the dog in quotation marks, but these are double quotation marks. So this is also important. You also need to do this or it will not compile. This is just a syntax thing for the language, so remember to put these things in quotation marks. Okay. So there we have it. We have a couple of examples of variables. Basically, x now is equal to 7, y is equal to 3.14, g is equal to h, and f is equal to dog. So let's go ahead and output it on the screen, see if it all works. So we put a cout, as you remember from our last tutorial, an output stream operator to output stuff on the screen. Now here, if you remember from our last tutorial, we put everything in double quotes. You don't need to do that here, because for variables you just put the variable name, and you really don't need quotes, because you're not outputting a literal thing. You're not literally outputting something on the screen. You're putting a representation of something on the screen. So you just put x, and this x here now, when it's going to show up on the screen, it's not going to be x, it's going to be a 7, because x contains 7, so that's what's going to be output on the screen. Just in case you're confused why I'm doing this, this is just to put a space in between each of these variables. I'm basically outputting a space on the screen here in between the two quotation marks. Y see G. And one more thing I want to mention is that you really don't want to have variable names that are like X, Y, G, F. These are global variables. Now, just quickly, I just want to summarize global variables. Global variables are basically variables that are going to be seen throughout the whole program. So it's very easy to get confused or something, use a variable when you don't want to use it. So if you're going to do global variables, I very strongly suggest that you make it very descriptive. So for character, instead of G, maybe you put character, something like that. Something that's very descriptive, because these are global variables. They're going to be used throughout your whole program. You can't use these variables again. So very important to make them very distinctive. Okay, but let's go on. H, well, why did I put H? I'm sorry, G. H is the literal. And then the last one is F. Okay, and then we put last thing, end line. Okay, so let's go ahead and save it and see if it works. Execute, compile, and run. There we go, it works. So as you can see, the X that we outputted here, see out X is actually a 7, because X contains 7. X is equal to 7. The Y here is 3.14, because Y is equal to 3.14, and so forth. So the variable names here are actually, so we put the variable name here, but what's outputted is actually what the variable contains. Okay, so there we go. That's our variables. We are probably going to be doing variable. We're probably maybe going to do like operations next tutorial. So why don't you guys stick around, learn more C++. It might be fun, might be educational, and thanks for watching. Make sure to subscribe, and I'll see you guys next tutorial.